Good morning, everyone. Welcome to the ECOFACT webinar. We would like to wait just 2 more minutes just to allow all the attendees to join this event. So we will start briefly. Good morning, everyone, and welcome to the ECOFACT webinar that we're organizing today. Today we will present the ECOFACT platform and the preliminary results that we achieved until today, since we are meeting the month 24 milestone in this project. I'm Serena Scotton. I work as project manager at RINA Consulting, and RINA is one of the partners involved in the ECOFACT project. I will briefly present you the agenda for today's meeting. As you see, we have 4 presentations provided by 4 partners in the ECOFACT project. Firstly, we will hear a short presentation about the overall project provided by Francisco Morentin, who is the project coordinator. Then we will hear more about the architecture design for the decentralized monitoring networks in manufacturing environment provided by Talib Sankal. And then we will also have a presentation about the ECOFACT digital twin platform and the OptimiST, concluding with a presentation provided by Emilia about dynamic LCA. As you can see from the agenda, we will, let's say, answer to all the questions gathered during the online seminar at the end of the project, at the end of this meeting. Therefore, I kindly ask to all the participants to please submit your questions in the questions channel that you can find in the control panel here in the GoToWebinar platform. Please, every time that you submit your question, please indicate the name of the speaker you want to address your query. This is an overview of the panel who will present here today. I inform the participants that you will receive the presentations that will be shared today via email, and you can also find it in the ECOFACT website in the next days, as well with the video recording. Now, without wasting any time, I would like to introduce Francisco, the project coordinator, so he can provide you with a project overview. Francisco, the floor is yours.
Thank you, Serena. I guess you hear me and you see me properly. I'm sharing my screen.
Perfect.
So, ready? Okay, so thank you, Serena. As you correctly said, and my name is Francisco Morentin. I work for CARTIF. I'm the ECOFACT project coordinator, and here I'm going to give you a quick overview of the project and a quick explanation of the project as it corresponds to the month 24 status. So, without more delay, I usually start with the ECOFACT formal definition. So we are a research project with H2020 Research and Innovation Program, and ECOFACT stands for Eco Innovative Energy Factory Management System based on enhanced LCA and LCCA towards resource efficient manufacturing. No, it's not a very friendly name, but we will explain it in the next slides. Okay, so we are a fourth year project, and we are more or less ending the first 2 years. So talking about the project consortium, we are 21 partners, because we have 2 Fraunhofer institutes, but we group them together. So we are 20 partners with some different countries, different profiles, RTOs, big companies, and small and medium companies. Okay, so what's our main objective? Okay, our main objective is to develop and demonstrate up to TRL 7 an eco-innovative energy factory management platform. Platform is the key word, based on improved dynamic LCA and LCCA towards holistic manufacturing sustainability. We will develop it later, but basically the idea is through the effective combination of ICTs, providing manufacturing companies a management platform regarding their energy and sustainability efficiency. So, talking about the project concept, what we call the ECOFACT platform, as an industrial platform, is divided in levels and components. Okay, so talking about levels, it has 4 levels. We will see it later. And on top of these levels, on the higher level, the apps and services level, is where the different components of the platform are being developed and will be implemented. Okay, so focusing on the levels, as I mentioned, these are somehow the typical levels you find in an industrial ICT platform. On the lowest level, we have the field level, where the connected products and infrastructure, the data sensors. Then on top of that, we have the edge control layer. Okay, and on the 2 higher levels is where indeed the ECOFACT platform is fully developed, and we have the data brokerage layer, which brings site information and cloud data services, and the highest level, the applications and service layer, where the different services are combined for different energy efficiency, sustainability, product design, and product management. Okay, so these are the levels of the platform. Remember, the platform properly is developed on the 2 highest levels. And regarding the components, I'm not going to describe them, just because indeed the next presentations will be specific for some of these components. We have considered 10 components divided in 5 types of components. We have considered interoperability components, operational management, energy aware manufacturing, environmental aware manufacturing components, and overarching components. And indeed, in the next presentations, we will have the explanation of one component related with interoperability, another one with operations and energy aware, and the final presentation will be related with dynamic LCA with environmental aware manufacturing components. So as a quick recap of the concept, which is the platform we are developing in this project, the platform is structured around 4 levels. On the highest 2 levels is where the different components of the platform are implemented. We also are considering demonstration activities. We will talk about that later. And around these components and demonstration activities, we have organized the working structure of the project, okay? And focusing on the time implementation, we have already finished the reference framework and methodology, which was the first work package. Now, the develop of the three components is grouped in three activities, which is interoperability components, energy and operations components, and environmental components develop. It's continuous, this develop of these components. Once these components are finished, they will be all together grouped in what we call the ECOFACT platform and the ACT framework development. And obviously, after that, we will continue, we will start, but we will finish the demonstration in what we call pre-demos and demos that will continue until the end of the project. As you see, we are more or less in the half of the project. Additionally to these technical activities or work packages, we have the classical horizontal activities of standardization, certification and regulation, replication and exploitation that obviously will start, will be more focused at the end of the project, and dissemination and communication. This is a clear example of a dissemination and communication activity. Talking about demonstration activities, we are a demonstration to market project, so demonstration activities are quite important for us. We have considered two pre-demonstration facilities where some specific components of the platform will be pre-tested in a very preliminary level, and we have the four demonstration facilities. The first demonstration activity is the white goods sector. We have the Arctic washing machine located in Romania. We also have the Athenian brewery in the beverage demo. It's a brewery in Greece. We have a food biscuit, a biscuit factory, a food biscuit located in Aguilar de Campo in Spain. And we have an automatic sector, the car body paint shop, not the whole car manufacturing processes. It will be a too complex demo, just the car body paint shop of the Tofaş automobile company in Turkey. So as a recap of the concept, because sometimes we get lost in this definition of levels, components, and demos, and so on, to express our concept in a more simple way, our idea is to combine production process knowledge, professional simulation tools, energy and resourcing planning and standards, and group it together in order to develop and demonstrate an integrated approach, first a methodology, but also a platform for boosting efficiency, but efficiency in terms of energy and also in terms of material resource at factory level, while also considering the whole value chain, okay? And it's curious because at the end, the idea here is quite related with one message which is more than 100 years old. So it's what is not defined cannot be measured. So here the idea is that what we want to do with the ECOFACT project, with the ECOFACT platform, is to develop a new innovative way to define, measure, and improve the energy efficiency and the environmental impact of complex modern manufacturers. We want to provide a tool for complex modern manufacturing processes, factories, in order that they can be able to, in a improved way, define, measure, and improve their performance in terms of energy and environmental impact, okay? And this is basically a quick summary of our project. Please follow us on the social media, on our web page and on LinkedIn and Twitter page. And that's all from my side. Thank you very much.
Thank you, Francisco, for your presentation. Now, I would like to introduce Talib Sankal, who is the next speaker, and he will provide us a presentation about the architecture design for the centralized monitoring in networks. Talib, the floor is yours whenever you're ready.
Thank you very much. Okay, I hope you can see my screen.
Yes.
Okay. So, yeah, hello everyone. Also from my side, my name is Talib Sankal. I'm working as a research associate at the Fraunhofer IPT in Aachen, Germany. Today, I want to present the current progress in the work package 2, which is mainly focused on the architecture for local data monitoring. So we're creating monitoring networks, especially in the manufacturing environment. So quickly to the agenda. First of all, I want to present you the design we already worked on, and then in the next chapters, the different parts of this architecture, starting with the smart sensors, and then the data acquisition at the local demo sites, and then in the end, the uniform part, which is the API to the ECOFACT platform itself. To give you a short overview where we are located as work package and where our work is located in the whole ECOFACT platform. So you can see here at the top the ECOFACT platform, which with all the services, so the digital twin and the LCA models, and we are located below the ECOFACT platform at the edge layer between the field, so between the local demo sites and the ECOFACT platform. So we gathering the data from the demo sites and offering it to the ECOFACT platform. Yeah, to have a other view on this, we are mainly doing the local data acquisition system here. So we are still at the demo sites. So our software and all the solutions will run locally at the factories and will share the information with the external ECOFACT platform. Our idea from the beginning was to connect to, or to try to connect to all the layers of the automation pyramid you can see on the left. So we're not getting the data just from a single endpoint at the factories, but we are connecting to different sources. For example, the MES, the SCADA, the PLC, or even the sensors with our smart sensor solution, which I will also present in the next slides. So yeah, to have again a view on the conceptual architecture, what we designed here is that we split this up in two parts. So two main parts. First of all, the platform architecture. This part is responsible, or this module is responsible to get the data from the field devices or from the factories or from the MES, the SCADA, the PLC, or the sensors. And then in this module, we have different pre-processing functionalities. For example, a first feature extractor to have a rough analysis on the data quality, data aggregation, filtering, or even pre-analytics and alarming, which will all happen locally. And then we have the uniform part of the edge layer, which represents a module which gets the data from the platforms, and so from the platforms on the left, harmonize it and offer a unique data model or a uniform data model to the ECOFACT platform, so that all the data the ECOFACT platform gets is normalized and in the uniform structure. So then I want to switch to the first part here, the smart sensors. So for this, we also have a short architectural picture here. So basically what we have here is a box where we can connect different sensors to it. The interesting part here is that the sensors are all in an industrial standard. So we have a standardized API to the sensors. And then we have a computing unit where also first pre-processing or feature extraction mechanisms can run. And then we have the interface to the edge, where we're sharing the data then to the uniform part of the edge layer. We run here with a containerization approach so that we have a high flexibility in deployment and orchestration of the software. But I have also another architectural picture which I will go in depth on that topic. Here I have a picture of the current status of the sensor box. So this is basically a small box where we have integrated a PLC where we can connect different industrial sensors. As example, also as a first prototype, we connected a PT100 temperature sensor here to the PLC. Then we have a computing unit, which is right now an Intel NUC, but we're working also on a solution which we can run this on another device, which is quite smaller, and that we can also get the box smaller, and it's in a more compact solution in the end. On the right side, you can see we have also a switch right now in it. That's because we also integrated the Ethernet, an external Ethernet port in the box, so that it is possible to also directly connect Ethernet-based communication systems to the box. For example, this could be also machines, and then we get the data also from these devices. So the current status of the software development. So as I said, we relied here on, or tried to do it in a most modular way. So all these software components we developed so far are containerized and can be deployed or can be orchestrated with Kubernetes. This has the huge benefit that in the near future we also can automate it, and we're currently working on this solution to automate it. So for example, a possible scenario where the user plugs in a new sensor to the PLC, to the box, that our modules can recognize the sensor and deploy the corresponding computation module as a container in the Kubernetes cluster. That lets to a flexible deployment scenario where we can deploy the software per need, and also that we can update and upgrade our software also in a optimized way through, for example, CI and CD pipelines. In the phase we are currently in this development is the adaptation on the specific Arctic use case. So the idea is here to use the sensor box for the photovoltaic cells at the Arctic demo site. And here we integrating different sensors like temperature, humidity, solar radiation, and air pressure to give the user forecasts when the solar systems have less power and when they need to be cleaned. So this is a use case which was shared with us from the Arctic side and from Arçelik. So I'm currently working on the adaptation of our box to meet this requirements. So coming to the next topic, the data acquisition at the demo sites. Here I also have a architectural picture. So we have 4 demo sites and 3 platforms we deployed there. So we have the Athenian Brewery, Tofaş, Guyon, and Arçelik demo site, and we deployed the Schneider Electric Wings and SmartCase solution for the platforms. Then each factory will have also a uniform part of the edge layer, which is normalizing the data and send it to the ECOFACT platform. So the 3 platforms I talked about are these ones. So we have the EcoStruxure Power Monitoring Expert from Schneider Electric, which is deployed in Tofaş and Arçelik demo site. We have the Artemis platform from Wings, which is deployed in the Athenian Brewery demo site, and we have the SmartCare platform from SmartCare, which is deployed in the Guyon demo site. So in the next slide, I have the current status of the deployment of these platforms. So these platforms act as a data aggregator for the existing data aggregation solutions, like for example the PLC, SCADA, or MES systems. So these platforms are connected to these systems at the factories and send their data to the uniform part of the edge layer. So the current status of the deployment here, we can see that the Artemis at the Athenian Brewery, the platform is already deployed and the data extraction from the local devices is working. There are still some issues with the firewall configurations for external communication. So right now the data aggregation only works locally, and we're working on enabling also the external communication so that we can share the data with the ECOFACT platform. And then the SmartCare platform at the Guyon demo site, the platform here is also deployed. And right now we're in the phase to enable the data extraction from the field devices, so connecting the, so getting the data from the MES and SCADA systems at the local factory. And this is currently also a work in progress. And then we have the EcoStructure platform from Schneider Electric, which is deployed at the Tofaş, or will be deployed in the Tofaş and Arctic factory. Here we are on the same level regarding the progress. The architecture discussions are finished, and the platform deployment is still pending. So we had a lot of discussions with the IT departments of the two factories, and now in the next weeks we are rolling out the platform and deploying it. So coming to the last part of the presentation, which is the uniform part of the edge layer and the interface to the ECOFACT platform. So again, the idea in this module is that we have a data broker for the demo site specific platforms. So we have different platforms deployed in different factories, and with this module, or with this part of the edge layer, we're aiming to normalize all the data. So for that we have a data broker in the first place, normalizing the data and storing it in a normalized database. And then the third component here is the API to the ECOFACT platform. So this will be in the end a REST APIs, which will share the normalized data to the or with the ECOFACT platform. So the first exercises we did in this topic was an exercise to create a nomenclature for the naming of the variables. So we have a list of variables which will be gathered, which are important for energy monitoring, and we did an exercise to create a nomenclature for naming, which is also a base for the uniform data model, which will be will be a result of the work here. So what we did for that was to define classes to separate the signals by type, and then defining codes for each class to create a unique name of the signals. This will be a commonly agreed coding for all demo sites and signals. So this coding, or the idea is this to use this coding also in the ECOFACT platform with the other components, so that we have a unified naming here. So the work is also still in progress. So the results I will show you in the next slides are preliminary, so they can be changed also in the next weeks. So this is how it looks. Basically, we have a prepared Excel sheet here with the signals on the left and the classes and the codes on the right. And on the farthest right column, you can see then the name which results from the codes. So as I said, we defined codes and classes and codes. So for example, we have the factory where the signal comes from. We have the line, the type, the system, the device, and the units. And then we have the codes for each factory. For example, in Archedic, we have the drumline 1, drumline 2, and so on. And to give you an example, and this is the final slide, how such a naming is concluding then, we have, for example, a signal which is the electricity consumption in kilowatt hours for cake puffing at inline 2 at Guyon, retrieved by the Emilia system. So we have the factory name Guyon, we have the line 2, we have the type, the system, the device, and the units. And these are creating then the name, which is then unique for each signal. And so each signal can be identified by this. Yeah, this was my presentation. I think questions will be in at the end of the seminar. But I want to thank you now for your attention. And yeah.
Thank you, Talib. Indeed, we will have a unique Q&A session at the end of the online seminar, and I would like to remind to all participants, if you want to ask your questions, please use the questions channel that you have here in GoToWebinar. Now I would like to introduce Andrea Perego and Matteo Porta, who will provide a presentation about the ECOFACT digital twin platform and the OptimiST. And first we'll start Andrea Perego. So Andrea, the floor is yours.
Okay, thank you. Let me share my screen. Second. Okay.
Andrea, sorry, we see you still, okay, nice, perfect. We can see the presentation, great.
Okay. Okay, so thank you everybody for being here with us. I'm Andrea Perego from One Team. I represent One Team, and I'm here to talk about the ECOFACT digital twin platform. We, as One Team, we are leading the work package number 3. And the aim of the work package number 3 is, as said, to develop the digital twin platform. So let's first have a look of where we are. So this is the overall architecture of the solution. The digital twin platform that will operate as an energy and resource management system is located in the higher level. So basically, we will get data from the data broker mentioned by Talib, and we will use this data to feed the different tools that will be hosted within the digital twin platform itself. Together with the dynamic LCA and LCCA and supply collaboration services, we will be part of the overall decision support system, as you can see from the picture, and the decision support system will be the tool that will be used from the final user to optimize the production planning. Okay, so let's have a look at the different components of the digital twin platform. So basically, we have from one side the digital twins themselves, so the 3D model. The 3D model that will be uploaded on the platform, that are uploaded on the platform, and all the relevant documents related to the models. Then we have the tools. So the tools that are and will be integrated within the platform. Especially, we will deep dive into the OptimiST tool, which is the more mature one. But there will be other tools we will see which are that will be integrated within the platform, and then we have also a data exchange layer that will be useful to exchange data with the other applications. So basically, we will exchange data through relevant APIs. Okay, so as far as concern the digital twin platform itself, as I mentioned, one of the components would be the 3D models. The 3D models have been modeled with Autodesk Inventor, and then are hosted in the Autodesk Forge platform using the viewer, so the Autodesk Forge viewer. And to create to model this 3D model, we've been using also Leica technology. You can see from this picture we have been physically in the factories to take measurements ourselves. In this case, we have used BLK 3D to take relevant measurements and then use these measurements in order to model in a proper way the factory itself, the relevant lines of the factory. Okay, so here you can see a picture of a screenshot of different models, but let's take a deep dive into the platform itself. So this is the user interface. As you can see, you have a menu on the left, and from the menu you can select the digital twin, so you can have access to the models, to the relevant documents related to the digital twins. And also, as you can see, you have a specific section for the tools. So the different tools as the OptimiST tool will be integrated there. And from there, you can, as a final user, you could have access to the different tools and run different simulations. So now let's see how the platform works, basically. So as I said, you can have access directly to the different digital twins. Then when you access the model, you can explore the model itself. You can zoom on the different components, on the different assets. You can hide an asset. You can unhide an asset. So let's say that this is useful for visualization of the different details. Then clicking on the different axes, you can have access to the different parameters, to the different data, metadata related to the specific access. And in this case, as you can see from the picture, there are also relevant sensors applied to the asset, and within the digital twin platform, we can see the data related to the sensor. We can see, for example, historical data, as you can see from the graphs related to the sensor. But from the other side, we can have access. We can see also real-time data. In this case, with a granularity of 5 seconds. So basically, the data is updated each 5 seconds, and this data is taken from the field. So we have just listened to Talib and understood how the data from the field could be retrieved, and this data can be visualized. The same data can be visualized directly on the digital twin platform in a graphical way. Okay. Okay, but as said before, this is only part of the digital twin platform, because another relevant part are the tools that are and will be integrated within the platform. So there are different tools that will be integrated within the platform. The first one, because it's already integrated and working, and we have also preliminary result, and as Matteo will show later, is the industrial energy flexibility and optimized management of generation asset tool, which we call OptimiST. Then we have the material flow simulation for predictive management of manufacturing processes, manufacturing process data, sorry, which is based on an existing tool, which is Siemens Plant Simulation. We have a production planning and scheduling tool based on an existing engine, which is the Gurobi Solver. we will integrate an energy simulation for dynamic operations management and cost optimization tool, which will be made on which will be based on Transys, and basically we will develop within this tool predictive maintenance model, and in order to help the operation and maintenance of the different machines. And last but not least, we have an industrial energy disaggregation tool. We will do energy disaggregation by product, so we will understand how much energy will be consumed by each product thanks to this tool. But as said, let's focus on the first one, on the first tool, on the more mature one, which is the OptimiST. And to take a deep dive into this tool, I leave the floor to my colleague. Please, Matteo, the floor is yours.
Thank you, Andrea. Good morning, everybody. This is Matteo Porta from RINA Consulting, and I'm responsible for the development of this tool that is called OptimiST, and that is a decision support tool that has been already integrated in the platform that Andrea described before, and has been applied to the 4 demo sites of ECOFACT project. What is OptimiST is, yes, as I said, a decision support tool that is based on some optimization algorithms in order to give the possibility for the facility managers to optimize their energy assets and introduce a sort of flexibility of the demand, managing the demand in a way that can be sort of provide some benefits, economical, energetical, and environmental benefits. The tool is, thank you, Andrea. The tool is composed mainly by 3 modules, module A, B, and C, that have different functionalities. Module A is expressly focused on the optimization of the generation assets with a fixed demand profile that is provided as an input to the tool. And the module B is focused on the management of the flexibility, considering a variable demand profile from the facility, from the factory. And then the third one, the module C, is specifically related to the optimization on the changeovers. As you can see in the bottom part of the slide, we applied those modules to the 4 demo sites. In Topaz, we are applying module A. In Arcelic, a mixed application of module A and module B. For Athenian Brewery and Guyon, we are applying module C. And what we are going to briefly show you today is the application of module C for the Athenian Brewery demo case, because it's the one that is already working and embedded in the main platform. The next slide, please, Andrea. So I would work briefly. Again, this is a decision support tool. So we provide advices to the facility manager in order to manage some section of the factory. In this case, for the Athenian Brewery case, we are talking about the packaging line, and so we can minimize the changeover time, redefining production scheduling. So the changeover times, the black intervals in the figure on the right side of this slide are the times that are between 2 different types of products. In this case, for example, different labels for the same bottle of a typical beer that is produced in a packaging line. And so when there is a change between a type of beer, a type of bottle, of a type of label, there is a sort of change over time that is spent because the machines has to be washed, or some ingredients have to be changed. And with this optimization algorithm, we can consider all the list of in this case of the bottles that have to be produced over a time horizon, and decide which is the optimal sequence of items to reduce this time of standby of the machines, because of, as I said before, some changing in the packaging, and this means that we can then have this outcome of a new production scheduling, in this case for the 3 packaging lines of Athenian Brewery, so bottles, cans, and kegs of beer. And the first results from the application of these algorithms, you can see here in the slide. The bottle make span over a time horizon of 1 week has been reduced by 20%, from 102 to 82 hours, and the change over time has been reduced by 60%. And this means that we have a benefit in terms of thermal energy consumption and CO2 emissions. You can go to the next slide, please, Andrea. Okay, so as I said before, we have this savings. So mainly 20% of bottle make span and 60% of changeover time. That is also reflected on thermal energy consumption and CO2 emission. Next slide. So this is a snapshot of what are the inputs that are required to run these optimization algorithms. So you can see that the algorithm need to know the specific consumption of thermal energy for each of the items that are considered. In this case, specific consumption of thermal energy for the bottles, the cans, and the kegs, and also for the electrical energy. It is needed the specific consumption is here. There is on this slide there is a typo, not cost, but specific consumption of electrical energy, and the same for water. And then some information about the codes of the items that have been produced. The initial time matrix of the changeover, a sort of initial value from which the optimization algorithm starts from, and then some other inputs related to the production capacity of the lines, and of course the costs, because this is an algorithm that is based on cost minimization. And on the right side of this slide, you can see the results in terms of graphical results. So we can provide a new scheduling over the considered time horizon after the application of this optimization algorithm, and in a graphical way to see how each product is produced time by time after, again, the application of this optimization. Next slide, please. So here you can see how this has been implemented in the digital twin platform. So there is a dedicated section where the OptimiST tool can be run. And of course, here you can see a list of the demo sites of ECOFACT project. You can select the demo site and then input the data that are required and then run the algorithm. Next slide. I think that will be the last one. No, this is the last one. Okay, yeah, you can see what was in the previous slide, the list of inputs to be inputted, and then some results in terms of CSV files, so the time series of the production line, the new scheduling, day by day, hour by hour, and all the operation. Yeah, another aspect to maybe to be highlighted is the fact that this information can be related to the 3D visualization of the specific component on the specific line to which they are referred. That's it from my side. Thank you.
Thank you, Matteo, and thank you, Andrea, for the very interesting presentation. Now we can proceed with the last presentation for today, provided by Emilia, who will tell us more about dynamic LCA, the framework of the ECOFACT project. So, Emilia, the floor is yours.
Thank you, Serena. All right, is it? You can see my screen. It's all good.
Yes, we can see it.
Thank you. Thanks. All right. So good morning, everyone. I'm Emilia. I'm from PRA Sustainability. We lead work package 4 on dynamic lifecycle assessment and lifecycle costing. Today, I will speak about lifecycle assessment because I only have 15 minutes. So that will be the topic of this presentation. And the goal will be to first very briefly introduce LCA for those who might not be familiar with the topic. Then I'll explain what dynamic LCA is and why that can be interesting. And then I'll quite quickly try to introduce the ECOFACT approach to dynamic LCA based on what we've learned in the project so far. So starting off, what is LCA? LCA is a science-based methodology to evaluate environmental impacts associated with a product or a service. And it's called life cycle assessment because we try to always consider the life cycle perspective, including raw material extraction, manufacturing, distribution, use, and disposal. Because in all of these life cycle stages, you might have opportunities to reduce the impact. In ECOFACT, we focus on manufacturing, of course, that's the main topic of the project. But we also, in the LCA, we also include the impacts associated with the production of the materials and components that are used in the manufacturing plants. And this kind of scope is called cradle to gate, so the end gate of the exit gate of the factory. So as you can see, the impacts that we measure don't necessarily cover the full life cycle impact of the product, but it's an important puzzle piece to understand the impact. And LCA is a well-established method. There are standards and so on related to how to do this, but there are also some challenges, and especially when it comes to scaling this up and making life cycle assessment mainstream so that we can have impact results on basically any product. And one of those challenges that we are trying to address with ECOFACT is what I here refer to as snapshot assessments. And what I mean there is that normally when we do an LCA, we look at the specific time period and we say these are the impacts per product, for example, in this defined time period. And of course that makes sense because it might change. But since data, so the input data that you use for this assessment also gets outdated quickly, these results that you had might not be valid for very long. You might do efficiency improvements in your factory, or you might change a bit the materials that you use in your product. And we also know that data collection is often time-consuming, resource-heavy, because there's a lot of people from different departments who might need to be involved. So companies often postpone a new assessment, a few years. So you might be working with outdated results for quite some time in sort of the standard way of doing it. And so what we're then trying to do with ECOFACT is to automate this data collection and results updating process. And like we heard from Talib, so we will collect data from the factories, and this will be automatically transferred to our LCA module, where we have flexible and expandable LCA models that can then recalculate the results when there is new data coming in, and there can be a continuous monitoring of environmental impact for different actors in the factory. So this is what we're trying to achieve in this project. And of course, one main benefit here is that you can then easily have new results that are up to date. But what it also means that you do this is that in principle, you could make these time intervals quite short, meaning that you will see how the impact varies on a short-term basis. And this is something that we normally don't see when we do LCAs. We normally look at an average of a year or something like this. So this is interesting also from a more research perspective to see how could companies potentially use insights related to these short-term variations in impact. And they could depend on things like if you have renewable energy generation, that might of course fluctuate, or you have loads like heaters or fans that turn on and off. So in the course of the project, we're hoping to learn more about how this could be used by companies. But in the remainder of this talk, I'll talk about mainly the steps of setting up your LCA project to get these kinds of results. And we have identified 11 steps that are needed to get to perform dynamic LCA the ECOFACT way. And I've here plotted them on the lifecycle assessment framework, which shows the main steps that you need to do in any lifecycle assessment study. And as you can see, the first 6 steps are quite aligned with the framework. We have a little bit more detail here related to data. And then we also have 5 steps that are really about the application. So this is about setting up this the dashboards and making sure that the visualization is meaningful for the user and so on. And I should say that in the project now, we've done step 1 to 5, and we're working also on step 6, but step 7 to 11 are still to be done in the future. So I'll touch upon them quite briefly, but just for completeness, they are also here. All right. So first of all, we need to define a goal and scope for our study. And here, just for simplicity, I'm using an example that's not an ECOFACT case, but just a made-up example where we produce a product which has 2 components, one made of plastic and aluminium and one made of steel. They're produced here in our factory. And the goal of our study is to have this continuous monitoring of impact to be used by internal stakeholders. And we say we will measure the impact per one product produced. We set the system boundary, like we said, from cradle to gate, so including the factory. And then we also need to define what our environmental KPIs are that we're going to measure. And we say here we do only climate change. And of course, within ECOFACT, we have a few more, but this is as an example. This is the goal and scope definition. Then step 2 and 3 include identifying data requirements and mapping the dynamic data to data sources. And normally you would see this as part of the goal and scope normally, but here, because this is so important for our project at least, we separated it to separate steps. So what you need to do is to know, yeah, what data do I need to do my calculations? Which of these data points should be automatically updated? And for those who are automatically updated, how often should this happen? And then you also need to know, where is this data gonna come from? So again, using our example, this is a list of data points that we listed for our product that we saw in the previous slide. And what you can see here is that the first two data points are said to be static, meaning that, for example, the bill of materials, so the amount of materials in each product, we say this is probably not going to change, so this does not have to be updated regularly. On the other hand, if we look at electricity consumption for the different process steps, this will vary over time, and we want to capture this. So then we say here we want new data every 15 minutes. And the last one example, which is different, is the last two rows here, where we talk about waste. So we know every 15 minutes we have the amount of waste, but this is about the share that goes to recycling and the share that goes to incineration. And this probably doesn't change very frequently, but in order to see how it progresses over time, we say we want new data here every month. So this is our data requirements, including the frequency. And then we also need to say, where's this data gonna come from? And that can be, like Talib was mentioning, these local data acquisition systems, for example. But in some, or you might have to add additional sensors. And in some cases, if it's not captured in the data that are in the systems locally, you could also have a solution where you prompt the user to input a specific value every month, for example. Once you know this, you will create your model. And this is, we've done this for each of the 4 demos in the project. And this is similar to any LCA, but what you need to make sure is that for each of these dynamic data points that we listed, these should be defined as a parameter in your model. So here, for example, we have for component 1, the electricity needed for the component 1 production. And then when there's new data coming from the field for this parameter, there will be new results calculated by the model. Then you have the model, and here, this is the case for ECOFACT, we don't yet have the direct link to the field, so there is not yet a stream of data coming, but what we can already do is to do a baseline calculation based on historical data, preferably over a year to avoid seasonal variations, and then you test your model and you create like a reference value that you can compare to when you start having dynamic results. That's step 5. And then also related to this, you might want to do sensitivity analysis. This is like in any LCA, identify critical parameters that are for which the model is sensitive and potentially improve your model. And then comes an interesting point, and this is, as I said, something we haven't really done yet. This is in the process of being done, to set up this direct link so that we have data coming automatically from the platform to the LCA software. And in ECOFACT, we build the LCA models in s.p.a Pro, which is a cloud-based solution for LCA. And s.p.a Pro has an API that can be where the calculation can be requested. So here we need to set up a module that, with these time intervals that we've defined, sends a new calculation request to s.p.a Pro and then receives back the results. Just finally, the remaining steps that we then haven't done yet are to configure data management and storing. So this is something we still need to do to make sure that you can trace back historical records, historical results. We need to configure the dashboards so that we visualize the results in a meaningful way, potentially configured for different users. We need to configure decision support functionality. So we heard before that there is this decision support system and the output from the LCAs are going to be used in some of that. So depending on that functionality, there might be things that need to be adapted in the model. And then the last step, and maybe the most important one, is to continuously monitor and improve. And this is when there is continuous impact results coming on the dashboards to really use this as a way to make continuous improvements on the environmental impact side, but also to make improvements to the model if by using it you see that more details are needed for specific processes, for example. So that was quite a quick run through of these steps. Just looking back at this overview again, we covered them all, but quite quickly. So that was all for me, and thank you very much for your attention. And I will hand over to Serena for the Q&A.
Thank you, Emilia. Indeed, we can start now with the Q&A session. One second, I would like to share. Okay, 1 second that I'm opening the questions chat. Okay, I see one question for Andrea Perego, asking what are foreseen as the next steps to be undertaken within the digital twin platform.
Okay, can you hear me?
Yes, we can.
Okay, so the next steps, as partially mentioned, will be integrated the other tools. The other tools we have shown in one slide within the platform. So we are proceeding. We are let's say proceeding very well with Matteo, with RINA, and we have been integrating each tool within the platform. And the other, let's say the next steps, the major next steps will be, as mentioned, integrating the other tools, and then give access to the results of this tool also to the overall ECOFACT platform, because as mentioned during my presentation, the digital twin platform, which will operate as an energy and resource management system, will be part of the overall decision support system of the overall ECOFACT platform, and so we will let's say we will provide the results of the tools running within our platform to the overall ECOFACT platform, so that the final user can have access to these results from a single platform.
Thank you, Andrea. And then I see one question for Talib, asking if you have any use cases in your company that's to integrate the smart sensor system.
Yeah, hi again. So we as company, we're not a company, we're more than a research institute. So we have a few use cases for this kind of smart sensors or sensor boxes, mainly integrated with 5G communications. So using this kind of boxes with a 5G interface. Yeah, there are various use cases, for example, in the machining, for example, milling machines, or for acoustic emission sensors. We have also this kind of boxes. Yeah, so there are various use cases.
Okay. Okay, thank you. Then going to Emilia. This is more a comment because I think you already briefly mentioned during your presentation, but if you could maybe highlight what is the main benefit of dynamic LCA for companies compared with the static LCA?
Yeah, no, thanks. Yeah, so as I said, the most immediate one is that you can easily update results, so that you don't need to go through the whole process every time of data collection and involving different stakeholders. So if you have that readily set up, it's of course a big benefit. But as I also said, I think there might be benefits that we don't really know yet. If we can have this kind of very detailed insight into how the impact changes over time, we might learn new things that we don't really know yet how companies might use. So that's also why it's an interesting thing to explore. But yeah, the immediate benefit that I see is this reduced time and effort needed for updates.
Okay, and Emilia, I've also received now one question for you, asking is if dynamic LCA is good for IoT shipping.
For what shipping?
IoT.
For IoT shipping?
Yes, this is what I've just received, yes.
I'm not fully sure I understand.
Tom Walsh, maybe, yeah, because I just received, so I didn't have the time to read it. Maybe, Tom, if you could maybe rephrase it, because then I see also another question from your side, and I'm not sure if this is referred to Talib or Emilia. Yes, okay. Yes, IoT meant as Internet of Things. So he said dynamic LCA good for Internet of Things shipping, thus to tracking the containers.
Okay. Yeah, I'm not.
Maybe. Okay,
now I see a different question, but okay. So what we're using, of course, is this data from the field. So it's built on an IoT solution. Let's say, I mean, Talib is the expert on that. But so the question is, maybe is this useful also for other industries, for example, logistics, shipping?
Yes, I guess that is the cut. Yes.
Yeah, and I think so. What we saw in the overview, our scope is including the upstream materials and the manufacturing, but not the distribution yet. But of course, if you have real-time data coming about distribution and knowing where things end up and how long they're transported and so on and so on, the model could be expanded with this life cycle stage as well. And then, of course, this kind of data would be very useful. So I hope I'm partly answering the question by that answer.
Yes, I think you managed to answer that. Then let me see here in the chat box. Then a question for Matteo Porta about the next steps and how you will develop further the OptimiST tool, if there are other features that you think you will develop in the next stages of the project.
Actually, we are working on implementing all of the 3 demo sites application in the platform, in the digital twin platform. And what we are seeing by the application and our experience so far is that the different modules are not so how to say strictly divided. They are connected all together because of course the generation assets provide energy to the different production section of the factory. And so this means that all the information and all the how to say optimization routine could be integrated together to provide how to say a unique optimization algorithm that can include the generation, a flexible demand, and some sort of changeover or storage in intermediate storage management. This, of course, is means that is a bigger effort, a computational effort for the optimization algorithm. But yeah, this is maybe the next steps to integrate all the models in a unique algorithm.
Thank you very much, Matteo, also for your answer. Then it seems that LCA is a hot topic. It raises a lot of interest. So I have another question for Emilia. As LCA practitioners, when can we have the possibility to use real-time CO2 emissions tracking in s.p.a?
Yeah, thanks. So I saw this question. I can, so maybe to clarify, so the API is there. So s.p.a can be called from external systems services, and so that you just, with the parameter numbers, the values, you get new results. So of course, this also depends on what kind of system you have yourself. But what we're doing here is, of course, the complete package. So s.p.a is one component in this big ECOFACT platform. So we couldn't do what we're doing without all the other components as well. But the API is there, and you can, in that sense, easily recalculate results when you have new values, if you have those values, let's say. I hope that's an answer to the question again.
Yes, thank you. So we are supposed to close the online seminar now because we already crossed 11:15. I just want to ask to the speakers if you want to close this meeting with a final comment or remarks.
Yes, I have one. Obviously, as project coordinator, I'm going to do the classical speech to the audience that please follow us in our social media channels, in our webpage. If you are not subscribed to our newsletter, go into our webpage and subscribe into our newsletter, because dissemination activities are important, quite important for us.
Thank you. Indeed, I would also like to add, as you see, all the speakers reported the email address in the presentations. So, of course, today we had limited time for discussing all the topics. But if you have any further questions or you want to engage further with the speakers, feel free to contact them. As you saw, the email address. Then, as I said, in the next days, you will receive a post-event email with the presentations. So you will find the email address also there. And you can stay in touch with us and with the speakers. And again, thank you for attending this meeting, and have a nice day. So I will officially close the online seminar now then.
Thank you very much.
Thank you.
Thank you.
Bye, everybody.